Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of difference of squares, specifically how we can factor them, and we'll do it in 5 minutes or less. So we are very comfortable with factoring trinomials here. So what happens if we see something like this? 4x squared minus 9. Now when we're used to factoring, we're used to seeing it like this: ax squared plus bx plus c. We know how to use the diamond method with that. But if we try to map this on top of that, we see 4x squared. There's no bx. I'm just going to kind of line it up like this. We could still use the diamond method, but hopefully our eyes will start noticing something when we're missing that b term, that bx term. So what happens here? Well, my a equals 4. My c equals -9. My b is, I guess we could just call it 0 since it's not there, right? And if we're going to use our diamond method, we know that a times c goes in the top, right? So that's going to be 4 times -9. And that's going to be -36. My b term goes down here. That's just 0. There's nothing there. And then I'm looking for ax over my factor, and then ax over my factor. So this is weird. I'm looking for two factors that multiply to -36, but then add to 0. Well, if those two factors are going to add to 0, right, and they're going to multiply to -36, one needs to be positive, one needs to be negative. But if they're going to add to 0, they have to be the same thing, right? So I can list out all my factors here, but we should be thinking, you know what? The only way to make that happen is if they're the exact same. So I need a 6 and a 6, okay? And then one's positive, one's negative. That's going to work, right? Because 6 times -6 gets me my -36. 6 plus -6 gets me my 0, which is what I need right there. So I can write both of these here, and I can say, all right, so my a term is going to be 4, right? So I can say 4x over one of my factors 6, 4x over one of my factors -6. And then I'm looking to see, can I possibly simplify? Yeah, I could divide both by 2. So that's going to be 2x over 3. So 2x over 3 is going to be one of my terms. And that's a positive 3, so I just write it like this. Same thing over here, but this is going to be 2x over -3. So 2x minus 3. Now, if I want to FOIL this out here, I could say, well, that's 4x squared minus 6x plus 6x minus 9. So these two cancel each other out. I get back to my 4x minus 9. Now, I did all of that with the diamond method. It's one way to think about it. But if we can notice that we have a difference of squares here, we can save ourselves a lot of trouble. This is actually on our mathematics chart, okay? So this is what we need to think of, okay? So if we see a binomial here, this is really just a two-term here, but it's an x squared and then just a constant, right? We're missing this bx. We need to first think, is it a difference of squares? Well, how do I know? Well, take a look at our a term. A term equals 4, okay? A term can also be viewed as a square, 2 squared, okay? So if I want to think of it as a whole unit here, this whole thing, I could say this is really 2x squared, because the 2 squared makes 4, the x squared makes x squared. And I could think of the same thing right over here. If this is my b term, right? b equals 9. So I could really think of it as a 3 squared, okay? So what I have here is 2x, and the whole thing is squared, minus 3 squared. And so what we have in our mathematics chart is we see this right here. If you see a squared minus b squared, what that means is this is a plus b and a minus b. It's called the difference of squares. So that means that I'm going to take my a, 2x, plus my b, 3, and then 2x minus 3, which is what we just did right over here using the diamond method. So that's how we can use the difference of squares.